Good morning, everyone, and welcome to today's webinar, which is organised by Recolight, the lighting industry's leading authority on sustainability and compliance. I'm Ray Molony. I'm the editor of Circular Lighting Report, and I'm going to be your host for the next hour and a half or so. Today's webinar is all about designing sustainable luminaires. Now, we have an excellent lineup of speakers, as you can see. We have Dave Hollingsbee, who's the Managing Director of Stoane Lighting. Simon Fisher, who's the founder and director of the product design agency FMark. We have Frank Thomas, who's compliance manager at ATG Airports, which is an airfield lighting specialist based in Warrington. Also joining the panel will be Nigel Harvey, the CEO of Recolight, and as I said, I'm going to be your chair till 12:30 or so. The agenda today, Dave is I'm going to kick off with some innovative luminaires that have caught our eye in recent months, some innovations, some developments that Dave is going to discuss what we mean by manufacture and what we mean by sustainable. So I'm looking forward to that. Simon will focus on designing in circularity into luminaires, and Frank will do a deep dive into material efficiency standards. And when the presentations are over, we will have a panel discussion, and here we really welcome your thoughts, your comments, and your questions, and we'll deal with those. And as I say, we'll finish at 12:30. Today's session is being recorded, and it will in due course appear on the Recolight website, so you can also listen again at your leisure. You'll receive the slides via MailChimp tomorrow, so keep an eye out for them. Check your spam folder if they haven't arrived. Now, my colleague Suzanne is taking care of the chat box, so if you have any technical questions or any other issues, please put them in there. She'll keep an eye on that. And if you could put the questions or your comments in the Q&A box, that'd be great. And I say this because that's the one that myself and the panelists will be looking at. Before we kick off, I'd like to put a few things on your radar. We've done 3 webinars already this year, and you can go back, look at them, fast forward, rewind, all that type of thing. We did one on LCAs with Max Robson. We looked at the new waste regs that are coming down the track, and we also looked at BS 8887, which is the new standard for remanufacturing. And you can see all of those. Go to recolight.co.uk events, follow the links, and you can see those. Yes, I mentioned the circular lighting report. I'm the editor of this, and we do all sorts of news on interviews with thought leaders, interesting products, projects, etc., and initiatives coming up. Again, you can follow us also on LinkedIn, and you can also go to recolight.co.uk for news and see all the stories there. Our big event is, of course, the Circular Lighting Live. That's on Thursday, 25th September 2025. We've got a new, bigger venue in the Minster building in the City of London. So get this in your diary if it's not in it already. We're adding lots of new features. We have the awards of the Build Back Better Awards, the lighting category. We've got new formats, Just One Thing micro talks. We've also got a moonshot panel looking at really ambitious ideas. Nigel will be joining that and sharing his ambitious ideas with us, I hope, Nigel. And we've also got a much bigger exhibition area, so it's less crowded. We're going to have more brands there, more stuff to see. And we've got it broken up into 8 sessions, so you can make the most of your day, choose what you want to see, shape your own agenda, so to speak. So you can get avail of early bird prices if you go to circularlighting.live and get yourself, reserve your place. Right, and to sort of kick off, I'm just going to look at some lights that we've been writing about on the Circular Lighting Report in recent months, just to give a little flavour of the trends, of what people are working on, what people are thinking about coming down the track. One a trend that is a bit remarkable and is quite new is that brands are experimenting and using wood in luminaires. big brands such as Fagerhult, Lictan, Artemide, Philippine, TRT are all experimenting, as well as specialist startups. If I'm to choose one, I would say this is quite, to see wooden downlights starting to appear in the market. This is from the Slovakian brand Setup Lighting. Now, that's a company that specializes in wooden luminaires, but usually their stuff is linear or pendants, and this is the first, downlight. It's been glow wire tested, and it has a special coating to make it flame retardant to DIN 4102B1. The firm says that its products can store up to 1 ton of CO2 per cubic meter, and you can also get it in oak, ash, cherry, and American walnut. So there. This is a French company called Kraken Lighting, based near Nantes, and they're taking things slightly further because they're making what they term technical luminaires, but they're using waste wood from reclaimed windows and doors. And this is their goods in department, would you believe? That's the wood that they're using. Now, this is a 600 by 600, is in the offices of a consultancy called GEFI Engineering in nearby Nantes. So they say that, Kraken make the point that this, using reused wood is a differentiator in a crowded market where a lot of people are vying for attention. Talking about wood, I need to give an honourable mention really to the Kviston from Fagerhult, and this is a groundbreaking luminaire in many ways. It's made from 70% recycled or renewable materials, including a body is made entirely of pine, plywood, housing with birch veneer. The internal reflector is famously made from discarded television sets. And the firm said this louver reduces plastic by 50% compared to the company's conventional microprism. Only 180 grams of virgin plastic is used in each fixture, and the packaging is also plastic free. Now, it's got milled end caps with a sort of an innovative construction, which means it only needs 5 screws are required for the complete fixture. And as you can thing. It must be the only luminaire I can think of whose bill of materials includes dowels. I think it's got a few dowels in it. So yeah, so just on numbers, it delivers 144 lumens per watt. It has passed the 0 to 95% humidity testing and the 650C glow wire test, and has full third-party accredited NX safety tests. This is the Super Duper Tube from sister brand Atelier Lictan. I think it's a great name, Super Duper Tube. It's an up-down, indirect linear suspended light, and it was designed in collaboration with Stoane, the Norwegian architectural practice. The company describes this as a fossil fuel-free light. It's made of biomaterials reinforced with hemp fiber, and the housing is made from the biodegradable polymer PLA, polylactic acid, a material derived from sugarcane. And we've seen a few luminaires over the last few years made from PLA, which is said to be compostable in industrial conditions. Now, the end caps, frames, louvers, and suspensions are all made from the same material. And as you can see in the picture there, that louver just slides into place, so there's no need for any fixings or adhesives. The addition of hemp leads to a big decrease in CO2 emissions, says the firm. So it's 50% standard. There's also a weight saving as well compared to luminaire of about 53%. The cable cover is made from a natural coloured linen. Cardboard is used for the cable locks and the gaskets to prevent light leakage. And Lictan also says it will assist in the recycling of the luminaire at the end of its life. In terms of controls, it's available with the wireless controls technology Organic Response, where PIR sensors react to presence and communicate with nearby luminaires using infrared and radio waves. Speaking of cardboard, another light I absolutely needed to include is this, which is the OptiClip Terra from Sylvania, and which kind of changes the conversation about what you can make a luminaire out of. This is a folded, not glued, and it's 100% recyclable. And it's made at Sylvania's factory in Saint-Étienne in France. Now, the company says that transforming cardboard from a packaging material into sort of robust light fixtures did cause them a lot of challenges, and they had to do a lot of testing and lots of design iterations. But here it is, and it's now out in the wild. So basically, it's got two replaceable light sources which kind of slot into this gap, and you clip them in using recyclable clips at the rear. And it also won a deservedly so a Build Back Better Green Award last year. This looked rather similar, but in fact is quite different. This is the DFR panel from Egg Lighting in Scotland. It's based on a kind of very different premise. It's basically designed for remanufacturing at the end of its life. So DFR stands for Designed for Remanufacturing. And Egg says it can be easily upgraded at the end of its life using the sort of the standard, the sort of the methodologies of BS 8887 that we heard about earlier. The optics, the LED module and control gear are all Zaga certified and can be interchangeable and swappable. And it has a TM66 circularity rating of 2.6, which puts it into the excellent category. This is the I think one of the first DC mainstream lights that I've come across. When I started to DC luminaires, this is Bell's 650 volt version of the Tecton, and it's I think it's one of the first brands to come out with a DC version of one of its main variants. Bell reckons this can shave an extra 4 or 5% energy saving, and this is the Tecton, which is very popular in factories and industrial units where you get long runs of bus bar based lighting, and lots of other services in there as well. Now, I'm guessing, but I hope somebody will correct me if I'm wrong. I'm guessing that the Tecton DC uses this. This is Philips or Signify's new 650 volt DC driver, constant current LED driver. And Philips must obviously, or Signify rather, must see a market for this, that they're doing this sort of investment. DC networks is something that comes up periodically down the years, and there's a lot more excitement about it now. What with renewables, etc., what with data centers. And the German electrical industry body has set up an open direct current alliance to look at how lighting can slot into this. And they're recommending that 650 volts is the way to go because of the way it minimizes losses. And there you go. That's what it's 650 because of the way the AC/DC conversion works. And this is Zumtobel have also teamed up with ABB to so that their kit marries well with the ABB, so you get a sort of a seamless system. Also from Zumtobel is this the Zuru pendant, and this incorporates plastic-free reflectors made of biocomposites and a housing made from recycled steel. And the company says it's based on their circular design rules for sustainable products. So it consists of 40 components, and it requires no welding and ensuring that all the parts can be easily replaced. Choose your own color and the surface of the housing, and any patterns, photos, and text can be integrated. And you can also have tone. This is the Mix 85 from Lucent, which is a downlight made from 86% recycled materials. Additionally, 90% of the components of the Mix 85 range are recyclable. It has efficacy of 133 lumens per watt, which is pretty good for a low glare downlight like this. And it's also compatible with all of Lucen's 50mm modules. This is the Radar Bio, which I think is the industry's first 3D printed biopolymer recessed downlight, spotlight rather. And it's made in the UK by the retail lighting specialist Shoplight. It's 3D printed as a single part, and it requires less time and effort to disassemble, recycle, and repurpose at the end of its life. And I think Shoplight are actually starting to take back some of their bio lights at the moment for rework and recycling under their take back scheme. And also you can print it to suit various hole sizes depending on whether it's a replacement or whatever, which is another positive. Yeah. So here's another 3D printed product. This is the Highlight from Signify, which is printed using, again, it's glow wire tested to 850C and has an efficacy of 196 lumens per watt. And, Signify really lent into the whole 3D printing thing. They're, easily the biggest in the market. And they've also got clients such as Marks and Spencer and McDonald's who are taking these 3D printed lights. And lastly, I wanted to include a product that was not just about, innovative materials or whatever, but just basic good old engineering. And this is a mini version of Fagerhult's long established streamer spotlight range. And it delivers 150 lumens per watt, which is quite remarkable in this type of format. It uses 3000K Bridge Lux triple BL LED chips with a CRI of 90. And that reflector you can see is from Miro. So that's it. Hope you found that interesting. Who's going to tell us about lighting and to dive into what we mean by manufacture and what we mean by sustainability. So I just there and then Dave, if you could start sharing.
Right. Thank you, Ray. Can you hear me okay?
Yes, I can hear you good.
Great. Okay, thank you. Yeah, some really interesting stuff in there. Thank you. But my job today is to talk to you about sustainable luminaire manufacture from our perspective. So I've been introduced. I'm Dave. I run Stoane Lighting, a sort of small to medium-sized luminaire manufacturer based in Scotland.
Hi, Dave. Can you turn your video on?
Oh, sorry.
And show your screen, yeah.
Oh, sorry.
Thank
I
you.
thought my share screen has already come through.
Yeah,
Okay,
all good now.
Okay. And you can hear me as video you need.
Yeah, if you could just turn your video on as well, Dave.
Okay.
It should be at the bottom left.
Yeah. Sorry.
Okay, great.
Okay.
Right.
Right.
Okay, right. Good.
Thank you, Ray. Some really interesting stuff in there. But my job is to talk to you about luminaire manufacture, sustainable luminaire manufacture. From our point of view, as a small to medium-sized manufacturer based in Scotland. So before I dive into that, there was just 2 points I was going to touch on briefly at the beginning. What do we mean by manufacture and what do we mean by sustainable? And then we'll dive into our approach to doing both of those things together. So what do we mean by manufacture? Well, we're not a supplier or an importer nor a white label operation, and sometimes those get lumped in there, but just for clarification, that's not what we do. We operate a model that is a blend of discrete manufacturing and job shop manufacturing. We make kit from scratch. We make distinct items to our own standard designs in a sort of production framework. We do sort of short run customs, and we do out and out bespoke specials as well. So there's three sort of flavors there, all made in-house here, facility in Scotland. So in terms of sustainable and what we mean by that, it's a term that's there's no firm agreed definition. So we, broadly speaking, go by this one. Sustainability meaning to us a meeting of our own needs without compromising the ability of future generations to meet their own needs. In addition to that, it's not just natural resources. We need social and economic resources too. So sustainability is not just about environmentalism. With regards to luminaires or lights, what we're talking about, this is not an exhaustive list, but the kind of thing we're talking about here is the raw materials, the journey that materials and components take towards that final product, the in-use energy in their afterlife, the durability of the product, its maintainability, customer support, the remanufacturability and that process afterwards. And, you know, back to the social and economic side of it, there's also the corporate governance side of things. In terms of the key point here, how do we, Stoane Lighting, approach manufacture in a sustainable way? Actually, firstly, we start with data. It may not be the most intuitive or most exciting part, but it's really, really important. It's fundamental to it, in our opinion, that your data is appropriate, that it's accurate, and that it's trustworthy. And one way of looking at that is if a customer truly trusts what it is that they're investing in, they don't need to over-specify, over-purchase. You know, get exactly what you need. Don't buffer your orders. Savings for you, client, and for the planet. The sort of data I'm talking about, I mean, there's an awful lot, but key points would be things like photometry, embodied carbon through TM65.2, circularity through 66, or full LCAs and EPDs, ideally through an approved and harmonized metric. Because to enable informed decision-making, you need to use metrics that permit apple-for-apple comparisons. If you're comparing data that's been gathered in different ways, both could be completely legitimate, established ways in their own right, but if they're not harmonized, not compatible, then they're not of, you know, they're of limited use when it comes to informing decisions. One of the ways we look at it, like it's kind of nicely summarized here in this quote from the Patagonia founder, Yvonne Chouinard. Knowledge is power. The more you know, the less you need. And in a similar vein, as we started to really get to grips with this, we realized it's an essential means to stamp out, demotivate people from greenwash. If you can't back it up with numbers, if you can't count it, then don't talk about it. Secondly, we make to order, and this is something that's just the way we have always manufactured, the way our business operates, and it's not for everybody, but it is a really useful foundation principle factor in sustainable manufacturing. So there's virtually no wasted stock. We only make a light because we know it's needed. It's going to be bought, and it's already been bought, and it's going to be used. So we don't need to have a sales team out there selling kit that was made speculatively. A bit like the previous point about, you know, why buy 10 when you can get away with 9? The best light for the planet, frankly, is the one that was never made. So beyond that, then there's the process control. So as a small manufacturer, it's a little bit of a rod for our own back, but we take pride and enjoy the fact that we're a sort of broad spectrum, a full spectrum manufacturer. We cover an awful lot of the process, you know, retaining quite greedily control over all sorts of stages, many of them listed here. This enables us to understand and to influence, you know, just about everything involved in the process. Right, that way through. No need for me to read all those out to you, but hopefully that makes sense. Over the years, and particularly as we really started to examine how we manufacture and how we can improve sustainability aspects of it, we developed what we call our quadrant design guide. There's a more detailed, granular version of it, but this is, I think, the most useful one for purposes of this webinar. And really, it was just realizing that you can get unstuck if you focus too much on any one aspect. I mean, it's all very well having a product that you've really drilled into the impact and reduced that massively, but the product doesn't last very long, or it's simply just so unappealing that it's not going to get bought, so it's not going to change anything, or it lasts forever. It really has really good durability qualities, but the performance is terrible. It's perhaps doing more harm than good, or it might just not be appealing because of that poor performance. So it's keeping these things in check. There's no one size fits all, no magic recipe. Every brief that comes to us or that we impose upon ourselves has a different combination. But by looking at all of these things from the outset, we stand the best chance of delivering something that balances these 4 key factors. Intellectual property and supply lines, that's important too. Developing our own designs and retaining control over where the bits are made or how they're made, a lot of it in-house, is really important. It stops or reduces the chance of obsolescence, delisting of components, and where that does happen, inevitably, it gives us scope to maneuver our way around and overcome these obstacles. So, whilst we've got the factory where we make stuff, and we also have the designs that we make too, we greedily retain control over those, so we know how and what's being made, and we can control the design of it, so that should things change in the future, should a component become obsolete or we can't get it anymore, we have the means to get around that. And if a supplier stops wanting to make a thing for us, or we've got the designs, we know them intimately, or we've maybe even made them in-house, so we can adapt around that. It now enables us to pledge long-term support, which is a point I'll come on to in a minute. And then looking at the process of the factory itself, examining that, something it's just good practice to do anyway, but from a sustainability point of view, you can learn a lot, and it's important that you do, including the parts coming in, bought or manufactured for us, and external inputs, whether it's your energy supply, couriers, even the commuting distances and methods of your stuff. So constantly looking at all of these things is an important part of it, and understanding that gives you control and eventually the ability to shift outcomes. Crucially, also an opportunity to spot gaps. Some of those gaps are unwelcome, but you've got to face up to them and address them. Some of them actually it can be quite attractive opportunities. So I'll touch on a few of those just now as well. So we've always manufactured things that quite robustly, built to last. So why not pledge to support them longer than that, and actually put that message out above the line, having good sustainable qualities that enable your product to last enables us to comfortably put a 5-year warranty out, and more recently to add another 20 years duty of care onto that, in full confidence, knowing that we can make good on that. So, perfectly robust kit that's had a hard life out there, and in its in its application can be brought back to us and brought back to former glory. So that kit lasting a long time, offer this remanufacturing service. Not only is it potentially saving customers money and obviously the planet resources, it's a commercial opportunity too. So gathering that up, turning that gap into an opportunity, we launched our Renew service, and then taking that a bit further. Okay, so Stoane Lighting, you offer this long-term, long-lasting product, and you offer the ability to remanufacture it. But my kit is a big, complicated chandelier integrated into a building, where it's an architecturally integrated array of spotlights. Can't really take it off site, but I'd really like to keep it in service. So again, another opportunity comes from that, and we launched our mobile remanufacturing service. So plugging these gaps, but also realizing opportunity at the same time. And the opportunities continue. So waste internal, by owning and understanding the process, we can identify waste. So this one's been around for a while, you may have come across it, but it's our PLP range, whereby powder coats, overspray dust is collected. not usually off the floor, but through the extraction equipment. And it's difficult to find a good use for that, or anybody that wants it, and you don't want to dump loose microplastics into landfill. You can bake it into bricks, and you can do certain very low-level interventions, low value, low return. Or, as we try to do, is to seek avenues for capturing it and escalating it up the value chain as far as possible. So with a circular designed luminaire, such as the ZTA, we can then create interesting forms to then capture this waste and put it to really good use. And that virtue become that gap becomes a virtuous opportunity. Overspray powder is a fairly small factor, I suppose, but more so a key component in what we manufacture is aluminium and aluminium waste. We source it where we can locally in the UK, and it's of a high recycled content anyway. And any surplus waste is normally sent back to a local recycler to be resmelted. But again, an opportunity there to do something more immediate and beneficial to us and the planet too. So we've developed a technique whereby we can capture that waste and on-site smelt it down and into an elevated product, whether that's a decorative pendant, and more recently we've got a downlight that allows us to repurpose that waste. And the material is free. It's financially free. It's very low carbon. It's the forge we use to do it is run off a renewable electricity supply. So it's fairly guilt-free material that we can indulge quite a chunk of metal at, which gives you great thermals for good performance and good longevity of the product too, as well as being this commercial advantage of not having to buy more material in. So looking at these things, it takes a lot of scrutiny and solving the design challenges and the manufacturing challenges is not insignificant, but by doing that examination, only then will you spot these opportunities. So also tracking and capturing this progress is important, and I didn't want to go through this talk without touching upon longer term goals. So the SDG goals and aiming for a net zero 2030 or net zero 2050, very much part of the conversation. And we did for a number of years now do 100% or more than 100% offset through carbon offset programs. But as we learned more and dived into this more, we decided that it wasn't the long-term solution anyway, but it felt too much like a kind of sticking plaster vanity thing. So we've decided for the time being to divert the budget and the resource from that into proper net zero goals, fully defendable program, which is well underway and there's activity happening, but it's very complicated, and we want to do it right. We want to do it in a way that is definitely achievable. And so honing that is taking us longer than we'd have expected, but it's a really interesting undertaking, and is yielding all sorts of shifts in behavior and company practice that we're capturing all the time. So any day or fairly soon we'll be able to put this out above the line in terms of a comprehensive net zero goal strategy that's fully dependable, and then perhaps reintroduce carbon offset for the small bit at the end that we may not ever, the last few percent that you can't impact and offset there. So that's very much a work in progress, but it's just because it's not above the line doesn't mean there's not a lot of work going on it. And just in general transparency here, I'm just showing our disassembly instructions, which go out with every product hosted online and accessible through the unique serial number on each product, whereby you can get material makeup, tools needed for maintenance, disassembly, information for recycling. This kind of data is useful for all sorts of things. So putting this out there, perhaps might be considered a bit brave, but it seems like the right thing to do, and perhaps is going to be legislated soon enough anyway. So having good data, make it available, and that kind of transparency we're finding works both ways. It inspires us to do better internally, and improve practices, because we know we're airing it externally. but also it attracts attention. It seems to inspire healthy collaboration and healthy competition. So awards, initiatives such as Green Light Alliance, the B Corp community has been really interesting. There's a whole talk there, perhaps, and ultimately, more recently, attracting or winning to these King's Awards. So that's not possible without having done all this diligence in the background and made a lot of it quite transparent. So that, in a nutshell, is Stoane Lighting's approach to sustainable lighting manufacturing. And I think there may be an opportunity, if I've not gone on too long, for questions at the end. Thank you for listening. And at this point, I stop sharing, and I think I'll see you with Simon.
Dave, thank you very much. If you haven't sort of sussed it already, then if it's Dave or Irena or Ali or anyone from Stoane, you see them advertised as speakers at any event, I recommend you pin your ears back and listen, because they really are walking the talk. So, and at the very forefront of all wonderful things from a sustainability perspective. I'm going to say a few words about designing sustainable luminaires. And actually, while I was researching for the one-day workshop that I successfully run with Recolight on several occasions, of a title of a similar thing for designing sustainable luminaires, I came across a really interesting white paper, and a hyperlink to that is on the presentation you'll get at the end of this session. And I've lifted directly out of that a really interesting slide, which was kind of explaining different ways of designing for a circular economy, and it sort of broke it generally down into 3 sections, and those 3 sections are the bits that I'm going to talk about in my little slot today. Clearly, it's going to be quite a high-level overview because I've got 15 minutes or so, but yeah, it was quite interesting that as an industry, we kind of become very heavily focused on the principle of recovery, leading to kind of remanufacture and the ability to disassemble, the ability to repair, the right to repair, and that's perfectly sound, and that's perfectly correct. But there are other ways to design products that, in addition to recovery, still pay service to the circular economy, and actually in most cases suit other applications in a more kind of robust way. So, we've seen through TM66 and the circular economy assessment methodologies, and we've seen through European Union's Eco-Design Sustainable Products Regulation, ESPR, that the focus very much has been on, are we able to change out light engines? Are we able to change out drivers? Are we able to recover and harvest components? Quite possibly reuse those components. Are we able to use biodegradable materials? And they all play into this kind of design for recovery bracket that we saw on the previous slide. But interestingly enough, there was a separate EU-funded program who unfortunately I'd love to have got involved in, because I think it was about 5 million euros worth of R&D investment went into the project. But I certainly know that Trilux were involved, Barton Back, the lighting designers, were involved, a whole raft of people, and it was called the Recolight project, and it was a real deep dive to understand kind of what's the best functionality for delivering circular solutions in product designs. And actually, one of the key findings of this output was actually designing for long life and designing for long service, and not including components like plugs and sockets, that add to bill of materials and add to material use. you know, is of equal importance or maybe even a greater importance than yeah, adding all these kind of plugs and sockets in the first place. So I'm not advocating that's the path to go, and you'll certainly get that as we move through the next few slides. But it certainly plays to the fact that you really have to consider the application and the product that you're developing for that application, and actually designing for long life or designing to make sure that you extend the use of your existing product should also be considered, as well as making sure that you can recover the product at the end of life. So I'm just going to give you a few examples of that. So a good example of designing a product for long use are those kind of application spaces where you really don't have the opportunity, or you don't want to go and service products on a regular basis. You know, classic examples are kind of marine applications, heavy industry, you know, use in mining, particularly where you don't want to have this kind of instant accessibility and instant interchangeability, because these things have got to be sealed up and, you know, they're exposed to really heavy elements. But maybe a more kind of understandable reference to that is Florence Pruss from Rycroft Lighting. It was a bedhead lighting unit that was designed and has been on the market for several years now. But this is a classic example of designing a product that's going to be in situ and used for a long time. And the way that the product was designed is such that, number one, it dealt with issues in that particular application of things like infection control. So we had a big cover that didn't have any kind of features in it so that dust couldn't accumulate. But within the luminaire itself, we had all of the lighting functionality required for all the individual needs for lighting a bed or a ward environment. So actually, technically, you didn't need to have any light in any other place in the ward, just at that space. And as you can probably appreciate, downtime in hospital spaces is a very expensive thing to do. So having something that's designed well, engineered in a way that everything remains cool, but is easily maintainable, is easily cleanable, and you don't have to maintain it very often, is a really plus point. Designing for extended use. Typical applications like that it's used quite heavily in places like street lighting applications, where control gear and light engines have actually for some time have been accessible and replaceable. Another decent example of that would be Ledvance's Indiva LED 2 product. This is a linear architectural product that was launched in 2023 under Ledvance's new Everloop initiative, which is a program which is ensuring that sort of every major element in the product is accessible, disconnectable, and replaceable. So the idea is that this housing stays in situ for as long as possible, and all the kind of lighting elements and the control elements can be accessed easily removed, easily replaced. But in addition to that, if things like control elements can also be added after the event. So if someone fits a standard product but then decides they want to make it smart, then actually you can go in and access the product and easily upgrade the product to a smarter solution. And then, of course, we have recovery. So, you know, I think this is the one that probably most people are familiar with, and this is this ability to, you know, fully dismount and disconnect and service a product at end of life. Another example of that would be recently launched Cat R from MVC Lighting, and this is a complete system play. This is an attempt to add weight to actually another initiative that Recolight and certainly FMark supports, is this kind of it's trying to solve or help solve the situation of kind of waste associated with Cat A scenarios. So this particular product, the luminaire body can stay in the ceiling, and then the the actual kind of lead cassette and the driver or emergency kit can be interchanged in multiple use phases. So much so that even in a Cat A scenario, you could put in a very bog standard kind of cassette and just get very basic illumination to lease the space. And then once leased, you can swap out and do a kind of a take back thing where you can put in, not just linear lighting features, but all kinds of other elements into this central compartment that will allow more of the product to be used in multiple use phases. Of course, we're in a phase of discovering biomaterials, and certainly if you look at circular economy assessment methodology through TM66, then you can be awarded, quite a number of additional points, for using natural materials or biodegradable materials. And of course, there's Ray mentioned it earlier with Signify of their largest kind of 3D print farm on the planet by the looks of things. But there are other companies such as Luminaire here that are doing some really groovy things and really just using the material that needs to be used. Another example of that would be TRT lighting and their Oaken street lighting product, and that's using natural materials for the main body and metal products that have a high percentage recyclate. They're not treated, they're unpainting certain elements, so we're really just sort of mitigating the embodied carbon and associated with the post-processing and painting processes, and I think yet to be surpassed LIA assured TM66 score of 3.1. So just to sum up my little section, I think it's really important that, whilst every product should have an element of recovery, that it's just understanding that in some applications, some products actually need to maybe forego some of, those kind of circular economy, milestones, to make sure that, and that actually long life and that extended use is just as credible as, making sure that something is fully demountable at the end of the day. Thank you for listening. I think I'm there or thereabouts on track. So I'm going to stop sliding my shares. I'm going to hand you over to Frank.
Forgive me. Can you hear me okay?
Yeah,
Yeah, sounds good, Frank. Just your slides.
I don't know what it was. It just dropped out.
it was a bit of connection.
Yeah. Okay. So just going to share my screen. It'll be a moment. Share. Share. Can you see the presentation okay?
Yeah, but you're not on full screen. There you are. Yeah, looks great. Thanks.
Thanks very much, Ray. So, good morning, everybody. My name is Frank Thomas. I work as a compliance manager in the aviation lighting sector, specifically for a company that manufactures, designs, and installs runway lighting. Now, although they keep the wolf from the door, they keep the fly fishing rods in my garage, all the work I do for BSI, I do free of charge. So the standards I'm going to look at covering today, I just want to state I've got no commercial interest in them. I just chair one of the committees that produces them. And that particular committee is GEL 111, which is electrotechnical environment requirements. So what I'm going to cover today, I'm going to look at how international standardization works, particularly in relation to material efficiency standards. Also look at, post-Brexit, where does the UK sit in the international standards community, look at how some European legislation, the eco-design rules, could affect us before moving on to look specifically at two BSI committees, the one I chair and a second one, CD11, which looks at material efficiency aspects for products within the scope of eco-design legislation. Now, it hasn't all been sweetness and light. There has been, I've got to admit, a slow takeover of these standards. I'll be discussing that and looking at what those barriers are. And then I'll conclude with a potential worst threat, and that is potential divergence within the international standards community on this. So I'll be covering material efficiency for the circular economy, the barriers to the standards, the potential impact of the EU's ASPR, and then looking at a two-region system within standards. So this is an oft-quoted diagram. There are different sources for this. It can be laid out slightly differently, but this captures the circular economy, I think, rather well. You've got raw materials going in, you follow it round, you've got residual waste coming out, waste management, trying to put as much back into the system as it possibly can, and making that residual waste area as small as possible. Now, the standards I'm going to be covering today, the way I interpret it, they can be applied across all of those areas except the light green region towards the bottom right on distribution. Now, let's look first at how standardization internationally should work. Now, many of you will have used standards, and you'll be aware that those standards, they can be company standards just used within a company. They can be pan-industry standards, or we can have national standards. So, for example, standards that were produced by BSI that are purely British standards. BS followed by a number. We can have regional standards. The most common ones we come across are the European standards, the EN standards, that get produced by CEN, CENELEC and ETSI, then get adopted by the national standards bodies amongst the CEN, CENELEC and ETSI members. So, for example, an EN standard, when it gets adopted in the UK, becomes a BSEN standard. But there are also international standards, for example, IEC and ISO standards. Now, where there's a common interest in a topic, and for most standardization areas, there probably should be anyway, you often get an IEC or an ISO standard that gets adopted regionally and then nationally. So, for example, the most common standard we probably come across, ISO 9001, was first actually published by BSI's BS 5750, moved into the ISO arena. ISO 9001 gets adopted in Europe, EN ISO 9001, then gets adopted in the UK as BSEN, and in Germany as DIN EN, and France as NFEN, etc., etc. Now, post-Brexit, things changed very slightly in the UK, and I must stress it was only slightly. So the three European standards bodies that publish these pan-European standards, CEN, CENELEC and ETSI, they are not EU bodies themselves. So you don't need to be an EU member state to be a member of those bodies. Post-Brexit, the BSI, and there were actually strong encouragement from UK industry, applied and were granted CEN, CENELEC, ETSI member status. There's some slight tweaks there in terms of how often you need to be audited if you're not aiming towards single market membership. But all in all, the UK remained a member of these bodies. And that's actually key for some of the discussion that will come up slightly later. And that is this. Under the European system, the aim is to have a single standard system. So any conflicting or overlapping national standards or international standards need to be withdrawn when an EN is published. So let's look at the first of these standards committees. Now, in the slides that Suzanne will circulate out to you, I've put a few links in there to the website for these committees, both the scope of their work, the standards that are under development at the moment, and the standards that are being published. So they'll be there for you to look at post-webinar. But GEL 111, I say electrotechnical environment, linking into the discussion on regional and international standards. I can't recall recently, in my engagement with the committee, that we've done pure national British standards. all of the work has been geared to providing UK input into the IEC Mirror Committee and the Senelec Committee. And we cover standards that look at the WEEE sector, any of the substances that are cited within ROSH, CLP regulation, etc., the analytical methods designed to test for those substances. Increasingly in recent years, we've been looking at design for ease of end-of-life treatment, the assessment of reuse content in products, and also product category rules for life cycle assessments. Recycled content has always been, has also been covered there. Now, this is another BSI committee, CED 1-1. It used to be part of the SCP range of committees. Now, these specifically do standards on material efficiency for energy-related products. It provides the UK input. Again, it doesn't produce or hasn't produced recently purely British standards. It produces or provides UK input into Senelec Joint Technical Committee, because it's Senelec Committee 10. And it looks at assessment methods, the design rules for products, dematerialization. Some people call that lightweighting. That's not a term I'm particularly keen on. Transfer of information. Generally speaking, trying to extend the lifetime of products, which my two previous presenters were discussing earlier, but also looking at the ability to use reuse components, recycle materials, etc. So what I've done there, I've listed the standards that are currently published under this particular committee. And as I say, they're all European standards that have been adopted as British standards. Note they're not international standards, they're not IEC or ISO. And that will come up later. Now, if I read these titles all out to you, you'd be bored by EN 45555, and I probably lost the will to live by EN 45557. So what I've done, I've highlighted there in yellow the particular aspects of material efficiency that these standards cover. Now, I spoke at a conference relatively recently on a slightly different topic, but I had this slide on the screen, and when we did the Q&A at the end, the first question I was asked was, from this slide, which do I consider to be the most important? It was actually it's not an easy question to answer for you. And the one I gave, and I think it's still true, is, and from my own experience within the EEE sector and my current role, I'd probably say the durability one, because the longevity of a product is something that customers appreciate, regulators appreciate, so that when we look at lighting, many of the eco-design improvements that we've made in our sector, we can closely link to the development and take-up of LEDs. Now, ATG Airports sells runway lighting. Nearly all of the civil airports that I've dealt with, they've all moved over to LED lighting. NATO airfields, slightly different. They're still very keen, many of them, on tungsten halogen. But for civil airports, it's all LEDs. Now, we have to meet the requirements of 3 standard setting bodies if we're going to deal internationally. The International Civil Aviation Organizations, the MOS in the US, and the FAA, the Federal Aviation Authority Administration in the US. Now, under the FAA rules, it's not in the other two, but under the FAA rules, if you provide tungsten halogen luminaires, there's no mention of what's effectively a warranty. However, for LED luminaires, we have to be prepared to keep those operational for 4 years. So although it's not linked to the standard, you can see how a regulator has decided durability is absolutely a key issue. Now, again, I'm going to talk anecdotally, but just as one thing I would flag up, if you're not even trying to implement these standards, but trying to implement the philosophies behind them. We have a customer who's a mid-sized airport in the UK, and they had 2 luminaires that they, out of a couple of hundred, that they needed to have some refurbishment work done. And as a sign of good faith to that customer, because they were a loyal customer and we wanted to keep them on board, we get them a variable price of how much it would cost to refurb repair these two luminaires. Oh, thanks very much, they said. And then within a week before we even reserved a purchase order, a lorry turned up with over 100 luminaires based upon us repairing them, refurbishing them at the price we'd agreed, based on two, which are purely a sign of good faith. Now, it wasn't really economically viable. We did it anyway, but it wasn't really economically viable for us to have done that if we'd known the quantity they were going to send back in the first place. So, you know, the application of these and how you implement these commercially needs to be carefully considered. I won't pretend that it doesn't. So, looking at those standards, I'm not going to go through. There's too much detail to cover them in massive amounts. But you know, the aim is to assist with the extension of product lifetimes, end of life treatments. You know, that they look at assessing the recyclability of ERP products and the recoverability. Accessibility is something they look at. Ease of disassembly. This is quite an interesting one. The feeling is when these standards were written that, you know, if you rate a product based on easy it is to disassemble, you're actually part way down the line. But I was at an appliance meeting, a European wide one, and one appliance manufacturer actually pointed out that for particular classes of domestic appliances, that the disassembly is relatively easy. It's the reassembly which is actually very time consuming. Now, as part of that, you know, when our tools required, because we don't want novices, amateurs, people at home accessing dangerous areas of AAA equipment. So it states in those standards for which aspects, which activities would require the use of a tool. And there's a little bit of mathematics thrown in there as well in terms of identifying the content of recycled materials or the amount of recycled material as a proportion of the total. And in terms of components that have been reused within a piece of equipment. Also looks at the availability of spare parts. So, take up with the standards. This is interesting. So, the GEL 111 standards I mentioned, they're almost good to go. You can take them and you can start using them. However, the CED 1 standards I've just been discussing a moment ago, these are what's known in the standards world as horizontal standards, i.e. they're generic. You can use them across a whole host of products, AAA products, but they're not vertical. They are not product specific. And to a certain extent, that slowed down the uptake on the use of these standards. Now, that doesn't mean they can't be used. I remember when I worked many years ago now in the water sector. Now, that water company used to stamp on all of its stamps, whether they're company standards, international standards, whatever. They had a company stamp which said, and I thought it was but witty and prescient, this standard was written to assist the engineer's brain. It was not written to replace it. So there's nothing stopping people taking these horizontal standards and applying them as best as they can. But ideally, and they were written for that purpose, they were supposed to present a framework which the vertical standards committees, the product standards committees, could take away and develop on a product by product basis. And that process has been slow. I mean, I'm not aware of any of the Senelec committees, lighting committees that are doing any work on this at the moment. In fact, the only aspect of that list I showed a moment ago where there has been some work was the part of BS 8887 on remanufactured lighting, which was the subject of a previous Recolight presentation. So generally speaking, take-up has been slow. The only one I'm aware of is actually within the appliance sector. Senelec TC59X has taken 45552 for durability, and it's applying that to develop a new standard that will be applicable to washing machines. So the question is, can we see momentum in the years ahead? Now, I'm going to look here solely within the scope of the framework for standardization. What I'm not going to look at, because I don't think the position is yet clear, is, you know, we are seeing some schism, shall we say, within the global trading system. Will any of that cause regions, nations themselves to start to backtrack a little on some of the aspects? That I don't know. But just looking at that standardization, you know, I worked for a producer, I worked for producers, you know, for a lot of my career. And the take-up of standards, the application of standards as a compliance engineer trying to sell them to the business as a whole, it's easier to get those standards taken up by business if the standards are de facto mandatory, either legally or become, give presumption of conformity with respect to directives, or customers start to ask for them. Now, 9001 is a good example there. Now, the EU, there's a saying, isn't there? And I don't necessarily believe in all of it. The US innovates, China replicates, the EU legislates. I don't believe in all of it, because it's not, I don't think it's particularly, it's not necessarily completely true for all of them. So, for example, Chinese innovation has astounded me over the last decade. But the EU does set legislation, and because of the size of the EU's market, it does become de facto the standard, because for those of us who make products that we would like to sell on a global basis, have a degree of commonality, a market that big is one that we obviously need to cover in our design briefs and our compliance. The EU has published its Eco-Design for Sustainable Products Regulation. It replaced the framework eco-design legislation, but I say it's another piece of framework legislation. What it does, it effectively tells product-specific piece of legislation what can and cannot go in there. Now, the delegated act for products, they'll be done individually, and the one for lighting, I can't say for certain here, but from what I'm hearing from the LIA, and they're heading via Lighting Europe, is that it's 2029 before we're going to see that. And I've stressed there that it is an estimate. So will the delegated acts lead to standardization requests, which tell committees, European committees, to write these standards that will support the legislation? And I think if that's the case, we will see a widening out of the number of standards sitting in terms of in a product specific area, and the take-up from it, particularly if they give presumption of conformity to any legislation. It might not just be the eco-design legislation. It could be, well, the one that's running in parallel, which is for green claims. Having procedures, standards that you can test to, assess to, and back up your green claims. But the sun may not be rising in a clear sky, I say here. It's disappointed me recently that IEC TC 111X has started to begin work on some of the topic areas covered by the European standards. Now, as I said earlier, often a standard begins development within the international arena, gets adopted in Europe, gets adopted nationally. From what I gather, and it might well be down to the enhanced scope of the ESPR, we're seeing, or we could well see, a divergence now in some of these standards. So standards within IEC will cover the same area as standards within Europe, but because of the European single standard system, the adoption of the IEC standards will be problematic. In fact, could well be impossible. Now, when I was working in appliance safety, I worked for a manufacturer that made controls both to EN and to IEC standards. And the IEC standard would be written parallel voted within Europe, and Europe would then adopt it. But Europe often produced what was called common modifications in order to suit their legislation. Now, one instance of that was that there was a particular temperature test had to be done at -25 Celsius in IEC, but because of Scandinavia's climatic conditions in Europe, that test needs to be done at -35 C. So yes, it was a more onerous test, but for a compliance engineer, it didn't produce no great problem, because I could test at -35. And because I tested at -35, I'd have my read across down to the IC requirement of -25. I wasn't doing any additional testing. What I don't want to see is additional requirements, requirements in the IEC standard and requirements in the EN standards, which would lead us into a position whereby actually you'd have to have different design procedures to meet both. That's not really where I don't think we should be. So what we've done recently within GEL 111 is to set up a liaison with the UK Mirror Committee to Senelec JTC 10, so that we can maybe work together, coordinate the UK input into these two committees to ensure that the differences hopefully are as cigarette paper thin. So that's the end of my presentation. I'll not take any questions now because I know there's going to be a little Q&A session afterwards collectively. So I'm going to stop sharing my screen.
Thanks, Frank. That was very interesting and very clear. Not something I can say about many standards presentations I've sat through over the years. Dave, if you could join us as well, that'd be great. And we could take some questions and comments from our delegates. First off, Diego Vickers, I'm guessing. Apologies if I've pronounced your name wrong. He's the design director of Lumino. Is saying, do the speakers have any thoughts on practical methods of on practical methods of marking extruded plastics with the number triangle symbol for TM66?
Very good. Hi, Jago. Yes, it's,
Jago, sorry, I got it wrong. Sorry.
Yeah. There's been a couple of ways we've investigated that. One is by adding a sticker, which doesn't sound very circular economy. The other one is by putting the material specification into the installation or the data sheet or the installation leaflet. So it's not directly on the Luminaire, but it's available in the data that should go part of your technical pack in your technical pack for your product or the project itself.
Dave, do you want to? Are you doing that?
It's a tricky one. Yeah, same with optics and loose parts like that. Yeah, the disassembly information we host per product, as I show, by the serial number, can give you that. But I think the actual clause in TM in the TM questions is marked actually on the item. Those are points we've left on the table for now. It's possible you could scribe them, melt them, laser etch them, those sorts of, we could do, but it's also got to match your processes in house, and it's not been something we've done yet. It's feasible, commercially feasible, possibly, but at the moment, yeah, if we wanted to drive that score up, that is one of the things that's on the table to be considered, how we'd go into that. I guess we're a smaller manufacturer with a very broad line card of products, so yeah, that would be a difficult thing to manage. Yeah, but yeah, I totally empathize with the question.
Okay, good. Okay, quick. Is my audio okay, by the way?
Yeah,
it is.
Okay, great. Okay, Johnny Gann, who's a product designer with Roper Rhodes, is asking, in general, what single design change has the biggest impact when it comes to reducing the environmental impact of a luminaire?
where do we begin there?
That's a big question. So, Simon, do you want to take that?
I think developing a product that's not a single-use product, right? Making sure that single lighting regulation and ESPR, well, now ESPR is started in a good way, which is actually to try and drive that agenda of making sure that we move beyond single use, and that light engines and drivers are accessible and replaceable. And if you imagine it, if a light fitting lasts for 10 years, 20 years, then actually if you can replace that light engine even once, you've just added 10 or 20 years to the life of a product, and you kept all of that initial embodied carbon, or nearly all of that initial embodied carbon in situ and in use. So it's almost impossible to answer that question with a soundbite, but yeah, certainly look at eco design and replaceability.
So upgradability. Dave, you'd echo that, right?
Yeah, it is really difficult. I mean, I showed the quadrant, and which bit of that are you talking about? It's a balance. But one of the things that was a sort of pivotal point on the journey for us diving into really examining and gaining data, I thought the embodied carbon was going to be more significant than it turned out to be. Not in every case, but just as a general rule of thumb, I was more often surprised by how much the in-use carbon was still a significant factor, because we are talking about a product here that uses electricity, uses energy. One of the talking to a colleague earlier this morning about, floor tiles and doing assessments on that, where it's, once it exists, it just sits there, whereas a light is burning electricity. And actually, if your product is designed to last a long time, you're measuring over that. That's still a very significant chunk of its impact. But then that's countered with, well, it depends where it's being used and what that energy, where that energy is coming from. Is it from a fully renewable grid, or is it from coal power stations? So yeah, really difficult one to give a simple answer for. Yeah, and you've got the balance where you're trying to have a low impact product that doesn't need to last particularly long because the building's going through regular updates. So you want to keep your embodied carbon in balance. So using materials that don't need to last as long as other materials that might. And we do a lot of long-lasting exterior stuff that's supposed to stay on the side of a building for 25 years. That's quite different from, let's say, a retail environment where the space is going to change. So why invest so much in there? You use these more slightly more fugitive materials, perhaps, but that's absolutely fine. They'll well outlast the 5-year brief. That would be no good on the side of a building in a hostile environment. So really complicated, but the in-use bit is still not to be overlooked, I think, until we are all using renewable energy, as a default.
Can I just add on to that? I think, Dave, you're right, and the answer will change over time, won't it? For the carbon intensity of the grid now, then energy efficiency of the fitting is arguably still the biggest impact. But as the grid decarbonizes, so embodied carbon becomes a bigger component, doesn't it? And it's going to become more important. So over time, that will have a much bigger impact on the whole life carbon.
Yeah. I mean, you could veer off now into the other part of sustainability I touched on at the beginning, the socioeconomic part, the impact on humans too. And if you're purely driving lumen per watt efficiency, you start playing around with the lighting the spectral recipe, your SPD, and you may save energy in use as well, the bit that I was just talking about, but you're harming humans because you're denying them essential parts of the electromagnetic spectrum. So there's another whole debate, maybe for another day, but it's not straightforward. But I think that debate is going to be had more and more often going forwards.
Yeah, I should point out that Nick Whitehand is making the same point, saying the energy consumption that is typically 95% of the carbon footprint of a luminaire. But as you say, Nigel, that is decreasing with every year that goes by. Armando Labasio, who's the R&D manager at Enedo, is saying the use of silicone resin in LED control gear, often in large quantities, severely limits the repairability and recyclability.
Very true.
A lot of nodding. Good. Okay. So what's the point? Point worth making.
In a way, though, that plays to the kind of comments I was making, that actually, in some applications, you won't want to try and veer away from that, right? You'd sort of accept that it's nasty, but if you've got a linear wall grazer that's on a building that's reasonably inaccessible, you'd want that to last a long time, and you want to minimize the potential of ingress, right? So, and actually that's still the best way of doing it. Now, hopefully we can find materials that are natural and not plastic based or silicon based that can achieve that. But yeah.
A really good question here from Bocek Chiplik, and I hope I pronounced your name correctly, who's the partner at Brandon Partners, and he's saying, with certification transfer, how can manufacturers support recertification or warranty transfers for reused luminaires? And I would also add another bit to that. How would you do that for remanufacturing luminaires that are not your own, that you didn't make in the past, or you don't know what's in them? And Frank, I'm going to pick on you for this one.
Yeah, so, I mean, I think that's a very valid point, because there are certification schemes out there for new luminaires. I'm not aware of any at the moment, and Nigel, maybe you've had some with terms of your 887 experience, that are actually offering certification bodies offering certification schemes for this. You know, it does cost money to get registered with UCAS to run a certification scheme. So it might well be, you know, as the market gets bigger, there actually becomes the demand for this. But I think the question is quite right. I'm not aware of any out there, and unfortunately, because I couldn't recommend a method of transfer for that. But it's something that then will have to certainly be considered.
Because, you know, critics of remanufactured luminaires say, well, hang on, if that's not your luminaire and you've done somebody else, you don't know what material's in there. You can't stand over that. Is that a valid criticism?
I think historically it is, Ray, but I think we're likely to see an improvement on that following the EU's introduction of a planned introduction of a digital product passport, so that the content of products through its life cycle all the way through to end of treatment becomes more visible.
Mm-hmm. And I should say that a remanufacturer on this would say, well, hang on, it's just a metal box. I'm happy to warranty that for 5 years and, you know, and stand over it.
True, but I was thinking more in terms of electrical safety, just as one example.
Yeah, okay.
I know that Nigel and I, you know, we're privileged to sit on that kind of working group that built BS 8887, and yeah, there was no shortage of debate around to what lengths we go to ensure that there's regulatory compliance on anything that's remanufactured. And, you know, I think BS 8887 does go a long way to address those concerns. You know, it's still guidance ultimately, but you know, I'm delighted that it's there because it does set a kind of a framework of kind of a minimum expectation. And fundamentally, luminaire standards are luminaire standards, whether they're a new luminaire or whether they're a remanufactured one, acknowledging that there's a little grey area in there of something that existed before and you're adding something new to it. But we're learning that as we go along.
Here's a kind of question I would say for you, Simon, from Mike Edwards. Some interesting wooden-bodied luminaires examples, but not sure a downlight would satisfy fire-rated downlight requirements and the panel, even if it had a TPA-rated diffuser. How would that work if the frame was combustible? Good to see materials being made from recycled material, but obviously not suitable for all applications. Yeah, if you could speak to the fire-rated issue with wooden downlights and luminaires.
Sure. The R&D that we've done around that with some of our customers is principally two things, and actually you touched on it, Ray. There's a kind of chemical treatment to make sure that you know some materials don't combust. It doesn't strike me in particularly as a massively sustainable solution to spray wood with chemicals, but in our experience we've found that actually material thicknesses you can achieve degrees of self-extinguishing which then will meet fire regulations with material thicknesses increasing. What I will then say to that is, of course, you could probably achieve the same thing with a 2 millimeter thick piece of aluminium that you could achieve with a 8 or 10 millimeter thick bit of wood. So there's that kind of calculation and evaluation that has to work out as to whether you're kind of, I mean, it's almost like the definition of greenwashing, isn't it? If you could use a very small bit of aluminium or a hossing great big bit of wood to achieve the same thing, you know. So it's about doing your due diligence and seeing where that balance lies. But you can certainly use wood in 850 degree flame retardant spaces by designing it correctly and making sure that that material is still self-extinguishing.
Okay, good. Kevin Shaw is saying, why are we worrying about LED replacement when no one seems to be researching actual LED life in fittings installed up to 15 years ago? The typically quoted life of LEDs is still on a predictive statistical calculation based on short-term testing. Now we have LEDs in more than 50,000 hours use. Surely someone should be testing fittings to measure actual lumen depreciation and failures to see if the life predictions were correct. I feel they are not, and LED lumens depreciation is much lower than was predicted.
Oh God, can I quickly jump in? I'm sure
Please
Dave's got something to say about that as well. But
please jump in.
But I mean, it's a fantastic, it's a brilliant point, and
great point, yeah.
And in actual fact, I can point to more than one instance when we've been working with the Regen Initiative on projects where we've done exactly that. We've put existing products that have been in situ for 10, 12, 15 years into an integrating sphere, and we've understood, you know, that actually it's depreciated 10%, and actually we're not going to do anything about that. We're going to put them, you know, they're going to remain in the ceiling because they're perfectly good. You know, and saying no to a job is just an acceptable, you know, solution for the right reasons, than you know, ripping out and replacing. So that's my 2 penneth on that, but it's a perfectly valid point, and there's no program to, you know, to look at long-term products, but certainly if you're being diligent, then actually you should do your work and kind of understand whether a product is perfectly fine and should be left well alone.
And again, my 2 penneth worth are slightly anecdotal. On runways, the luminaires that are installed there, they're not permitted to drop below 50% of their original candela value when they're tested. So at a runway centre line, 5,000 candelas, and there are state-of-the-art measuring equipment out there that go down the runway on a regular basis, measure these the ISO candela output to assess if the runway is still functioning. And you know, as you say, it's very rare that it's down to poor LED performance. Most of it is down to a requirement that the prisms and luminaires are cleaned on a regular basis and maintained. If they're maintained, they will last for many, many years.
Yeah, anecdotally, I think is the key word here. We see stuff come back for remanufacturing too, and yeah, cleaning is an interesting one. We kind of saw it happening as it used to be a halogen lamp would need to be thrown out and replaced, so the cleaning cycle wasn't so important. Focus perhaps was, but where things can be left alone for so long, yeah, dirt accumulation can outweigh LED depreciation. Anecdotally, installation and early LED failure, just, you know, you get the odd rogue failure with any piece of electronics, that's a small factor, but I think we're agreeing that anecdotally, once in use and settled in, it's generally outperforming you know, the cautious stats that were delivered with the product, and actually our limited experience of it, when stuff comes back for remanufacture, yes, you do sometimes find LEDs that have started to deteriorate comfortably outside of the stated times I'd had, but actually that's still not the reason they've been returned to us. More often than not, it's the driver, capacitor's gone or whatever, or some electrical component in the track adapter has just got oxidized or something. And probably the most common one, and even that's not a huge issue, is potentiometers that have been left in one position for a long period of time, even in a dry environment like a gallery. They'll just seize up, or they'll accumulate dirt and oxidization. And yeah, so the fixation on the LED is the sort of key point of attention, which I suspect is Kevin's point, is maybe a, you know, needs refocused onto other components, because it's, you know, your luminaire is only as good as its weakest component, and if it's not the LED, then look at the capacitor, look at the potentiometer, look at the cleanliness of the lens or whatever.
Or the plane landing on it.
Oh yeah, yeah, you've got that problem. Yeah, Greta Smetanite, from, I believe she's from DRK. Greta, apologies if I've mangled your surname. Anyway, Greta is standing up for wood, and she's saying hooray to those companies using recycled wood and boohoo to those using new wood. Modern forestry is extremely destructive and focused on producing quick wood yields rather than protecting biodiversity. Such forestry approach has extremely negative effects. Driving through Wales, you can see plenty of such wood plantations, which are not only an eyesore but an ecological disaster. And similarly in Slovakia, Lithuania, and other parts of Eastern Europe, products made from raw wood should be perceived the same as products produced from virgin plastic. Just because product can be taken apart and recovered does not justify cutting a tree. Anyway, interesting to get that perspective on wood. And we've come to 12:30, so I think we're going to wrap up there. We've covered all the questions and comments. So thank you for taking those in your stride, and thank you for coming along this morning and sharing your knowledge and experience and insights. We will be sharing the slides tomorrow lunchtime on MailChimp, so keep an eye out for those. The recording will go up probably on Monday on the website, so you can go back and watch the recording, etc. And we hope to see you all on Thursday, the 25th of September at Circuit Lighting Live at the Minster Building in London. More about that online. And it remains for me to thank Nigel, Dave, Simon, and Frank for coming on this morning and telling us all about sustainable luminaires. Thanks, guys. Appreciate it.
Thanks, everyone.
Pleasure. Thank you very much.
Thank you, Ray, for hosting us so effectively. Thank you.